Yes, Ewone.
Okay, fine. Today we are going to look at the phosphorus. Like in our previous classes, we have looked at the nitrogen, sulfur. Today we are finalizing our topic about with phosphorus. Now let's see some of the facts about phosphorus. Phosphorus, it is a non-metallic. Phosphorus, it is a non-metallic element. Mean to say, it is not a metal. It is not a metal. The same with the sulfur. We discussed that it is also a non-metallic element. Therefore, since it is a non-metallic element, it cannot conduct electricity. We can relate with the wood, like in Tengo, silver can conduct electricity because it is a non-metallic substance. And this phosphorus, it is found in group number 5, period number 2 of periodic table. Ena ananena kuti tidzakambirana za periodic table, then maybe I have to organize a day, maybe tomorrow we can discuss details about periodic table. And this element is not found as a free element. Therefore, it is found as a compound. We cannot have a pure phosphorus, but this phosphorus, it is found in a compound. Okay. And this element, which is our phosphorus, it also plays a major role in agriculture areas. Like it is used in the manufacturing of fertilizers. Let's continue. Let's look at the sources of phosphorus. We have got 4 sources where we can get our phosphorus, like crab shells. Then we can find phosphorus in a coal, in a banana peels, as well as in the metal ores. Examples of the metal ores where we can find our phosphorus, it is in calcium phosphate. Calcium phosphate, it is one of the metal ores where we can get phosphorus. So the following are just some of the sources where we can get phosphorus. Let's go to the extraction process of phosphorus. How can we get this element? That's extraction process of phosphorus. The same, like nthawi za nitrogen, tinaona kuti how, like the process of getting the nitrogen, like isolation of nitrogen from air. The same nthawi imene timaona za sulfur, there is a process called flushing process. It is like extraction of sulfur from the underground. So now let's see about the extraction process of the phosphorus. Rakauri ufati pange extract phosphorus, timayuza like we have a diagram. Diagram athu tili ni ma carbon electrolytes, then tili ni this inlet. It is an inlet for calcium phosphate. Remember, one of the sources for the phosphorus, it is calcium phosphate as one of the metal ores. It is also an inlet for the coke and sand. Then you go to this one. This one is called electric furnace. Electric furnace. It is called electric because of these electrolytes. Mwidula ababa kangati pachika process imene machika ababa, it depends whether we have electricity or not. Then you go to the slag. Slag, it is like my waste products after our reactions. Then you go to this one. This is our outlet for the slag. Remember, the word slag means the waste products after the reaction. While this part, it is for the inlet. Then we have also another outlet mainly for the carbon, for the phosphorus carbon monoxide, okay, like a gas. While for this one, it is like water as well as a solid, this outlet. Then this is our chamber. This is our chamber where the reaction takes place. Then this part, it is our carbon lining electrode. Remember, this process, it is done in the presence of electricity. That's why we are having the electrolytes. And on these electrolytes, we are seeing that the electricity which is coming in, it has got 400 volts. This is all about our diagram. So now let's see in details how this extraction of phosphorus takes place. We have to look at it in details. Okay, so now let's start. Before going to the process, to the actual stages or steps, any question about the diagram? Because if you understand this diagram, then the steps will be easier. Any question about the diagram? Mhm.
tikayang'ana diagram process yopanga extract kuti tidziwe kuti this is now a phosphorus akutuluka pa ndipo.
Okay. Another question.
Ine sinamvese koma kuti zuma ambira pali zuma kathera pali.
Okay. Another question. Okay. Kwambira ndinene kuti we have got this inlet. The first point like of our diagram, it is for the inlet because it is the inlet which brings in the substances or the reactants for the reaction to start taking place. Okay. Then you have this inlet. This inlet, it brings the reactants, our reactants. Okay. Have got the reactants calcium phosphate as well as the coke and the sand. All these substances, they are getting into the inside of our electric furnace by this inlet. Nde tikuona kuti these substances are getting direct into our reaction chamber. In the reaction chamber, tuna kuti tili ma electrolytes. These electrolytes that are there to conduct electricity, because the extraction of phosphorus, it is done under the process of electricity. So tili ma electrolytes athu amene mukuona awa. amene aupanga bring the electricity of 400 volts. Because of this is our reaction chamber. Zinthu zikapanga react timakhani ma waste products. So these waste products, they are called the slag. Can be a solid or like a liquid like. Okay, so this slag, it gets out of this reaction chamber via this outlet, and in the process we have we will see that there is also production of gas like carbon monoxide. Carbon monoxide amakhalanso ni outlet yake imene ili pamwambapo. Outlet limene pamwamba, it is for the gas, pamene outlet limene ili pansipa, it is for the solids as well as for the liquids. Now let's see the details about this extraction process of phosphorus. Titaona process, titaona step, mwina tizithanso kubwereranso kudziona pa diagram kuti zikukhala bwanji. Okay, so the first step says phosphorus is obtained as white phosphorus by reduction of its or called calcium phosphate. Remember, one of the sources for the phosphorus, it is calcium phosphate, which is a metal ore. Metal ore called calcium phosphate, it is one of the sources of phosphorus. So it is like we are first, like step 1 bit, is like we are having calcium phosphate. We will use this calcium phosphate for us to obtain phosphorus. Then second, sand and coke. Coke, like some books they say, although it is the same as carbon. Then sand and carbon are fed into the electric furnace. Step number 1, it is like we are getting the calcium phosphate as a source for the phosphorus. Step number 2, we are taking the sand as well as the coke and they get fed into the electric furnace. Then going to the diagram, our diagram, like for the step number 1 and step number 2. Step number 1, it involves the like kuti tikupeza calcium phosphate. Mu calcium phosphate nimene tipezemo phosphorus. Okay, then this calcium phosphate ikulowetsedwa into the our electric furnace, specifically into the reaction chamber via this inlet. At the same time, we are taking the coke as well as the sand into the reaction chamber using the same inlet. The function for the sand and coke, it is there to increase the surface area for this reaction. Okay, the function of coke and sand in this reaction, it is to increase the surface area so that more reaction can take place. So by reaching so far, we have seen the step number 1 and step number 2. Then let's go to step number 3. Step number 3, the electric current supplies high temperature of about 1450 degrees Celsius. Then let's go back to our diagram. Step number 1 and step number 2 zadutsa, mean to say these calcium phosphates komanso coke as well as the sand tsana kupezeka mu our reaction chamber. zitafika mu reaction chamber, then we go to third step, which says because in reaction chamber to tilima electrolytes. The electrolytes, they are there to supply electricity. Okay, the electrolytes, they are there to supply electricity. So these reactants occur from reaction chamber 2. Then we can switch on we can turn on our switch. Then these electrolytes will now conduct electricity. After conducting electricity, they have raised the temperature of the reaction chamber to about 1400 degrees Celsius. Okay? Nde funso lizibwebona kuti nchifukwa yani these electrolytes have raised the temperature to about 1450 degrees Celsius. The significance of this electricity of this high temperature, it is to promote the reaction between calcium phosphate and silicon dioxide, producing calcium pentoxide. Calcium phosphate masuko ku understand afika mu reaction chamber. Then carbon electrolytes apanga conducting electricity. Arapanga conduct electricity, tikuona kuti apanga raise the temperature inside the reaction chamber. The rise in the temperature of reaction chamber ipangitsa kuti the chemical reaction yambe kuchitika. Chemical reaction itambo kuchitika, tikuona kuti there is a reaction between calcium phosphate. Remember, calcium phosphate na amene analowa pa inlet patu ukafika mu reaction chamber. So zopeza kuti calcium phosphate watu akupanga react with silicon dioxide. This silicon dioxide, it is a substance which is also found in the reaction chamber. The calcium phosphate atapanga react with silicon dioxide akupanga produce phosphorus pentoxide. Ndekuti step number 3, product yathu, it is now phosphorus pentoxide, which is formed when the calcium phosphate has reacted with silicon dioxide. Then for product yathu, then let's go to another step, step number 4. Remember, by step number 3, product yathu ni phosphorus pentoxide. So now let's see the step number 4. This phosphorus pentoxide now apanga react with coke or carbon to form phosphorus and carbon monoxide. Mwaona? By step number 3, product yathu inali phosphorus pentoxide. By step number 4, we have seen that phosphorus pentoxide has now reacted with coke or carbon to form phosphorus and carbon monoxide. By reaching at the stage number 4, then tapanga produce phosphorus. Kwa step number 4, suti product yathu ni modzi kuti ni phosphorus yekha. No, we have got phosphorus as well as carbon monoxide. At every reaction, in every chemical reaction, there is a byproduct or there is a waste which is produced. So in the extraction of phosphorus, our waste, it is called a slag. Okay? Then this slag is tapped off from the bottom of furnace. Then let's go to our diagram. Our diagram like tidapita pasi kwambiri tili ni outlet. Okay? Para election yachitika ndikuti ma waste products awa pakaseto at the bottom. Then at the bottom have got the outlet. That outlet it is there to drain the waste products which have been produced in the reaction process. Then tini outlet ya mwambayi. Outlet ya mwambayi it is there to drain carbon monoxide komanso phosphorus. Okay? And the type of the phosphorus which is produced in this process, it is called white phosphorus. This white phosphorus is then converted to more stable allotropes called red phosphorus. Then tione kuti atamene kuti white phosphorus komanso red phosphorus ndi chani. Then tiziona in our next pages. Before going further, nungopanganso explain in summary. Koma ndiuza diagram. At first, tilenga calcium phosphate komanso koko ndi sand tizilowetsa mu reaction chamber of our electric furnace via this inlet. That's step number 1. Step number 1 ikukamba za calcium phosphate kuti tamutenga tamulowetsa mu reaction chamber yathu. Step number 2 ikukamba za coke komanso sand kuti tawalowetsa afika mu reaction chamber yathu. Remember, we have discussed that the function or for the significance of coke and sand, it is there to increase the surface area for this reaction to occur at a very high rate. It is there to increase chemical reaction by increasing the surface area. Then step number 3, tukupanga switch, tukupanga turn on our electricity. Then we have these carbon electrodes. These carbon electrodes apanga conduct electricity. Arapanga conduct electricity, apanga cause rise in the temperature of our reaction chamber. Reaction chamber to temperature ikwera to about 1450 degrees Celsius. The significance of having this high temperature, it is there to promote the reaction. Like in terminate monazam nitrogen, ionic collector of nitrogen. Tinakambia zone kuti nitrogen it is only reactive at high temperature, but at low temperature it is not reactive. The same in this one. The high temperature of our reaction chamber, it is there to initiate our reaction. But the reaction between the phosphorus and between the calcium phosphate and the silicon dioxide. But step number 3, product yathu it is phosphorus pentoxide. Ndipo step number 3 tini product yochedwa phosphorus pentoxide. Then this phosphorus pentoxide ipita ku step number 4. Ku step number 4 tikuona kuti phosphorus pentoxide akupanga react with coke or carbon. Atapanga react with carbon, this phosphorus pentoxide apanga produce phosphorus komanso carbon monoxide. Remember, in every chemical reaction there is a waste product which is produced. And in this process, our waste product, it is slag. It contains like the solids as well as some liquids. So it is drained by using this outlet. While monoxide, sanga ni gas, so gas it is less dense. Then apanga drain using this carbon monoxide. The type of phosphorus which is produced, which is extracted here, it is called white phosphorus. And this white phosphorus is now converted to more stable form of phosphorus called red phosphorus. Ndekuti chimecha clear bwanjo kuti tione kodi atamene kuti white phosphorus ndi chani kapena atamene kuti red phosphorus ndi chani. So before proceeding, any question about this process? Any question?
Phosphorus mpaka extracting amene akuita limodzi ndi carbon monoxide kapena iye amakhala kuliro pamene tamupanga amatulukira kuti.
Another question.
Inetu tikupeta mudati phosphorus anwetu ipanga contact electricity ndapapa electricity ibwera bwanji.
Another question. Okay, in terms of electricity, yes, phosphorus is a non-metallic element which does not conduct electricity. But I said phosphorus it does not exist as a free element, okay? But it exists in a compound. Like our compound of phosphorus, it is calcium phosphate. Mean to say this compound has been formed by reacting calcium phosphate komanso oxygen. So this compound it is able to conduct electricity because we are having calcium. Remember, calcium it is a metal. That's why there is conduction of electricity. But phosphorus its own does not conduct electricity because it is a non-metallic element. But because of we are having calcium, which is a metal, that's why there is a conduction of electricity. In terms of like the anafunsa kuti phosphorus wathu akutulukira patipo nimene anafunsire. This is our just reaction chamber. Tini outlet iyi komanso tili ma outlet, tini inlet this one komanso tili ma outlet awiri. Iyi it is for the waste products. Pamene iyi ni imene ikutulutsa phosphorus komanso carbon monoxide ilinga kuti ikutulutsa zinthu ziwiri. At first, remember this reaction it is done at a high temperature, which is 1450 degrees. So our phosphorus it is now existing in like a gaseous, like part of gaseous state. Kapena kuti upanga close to the gaseous chifake kukhanga tutulukira pamwamba. Remember the type of phosphorus which is produced here it is a white phosphorus, which is very unstable. So after production of white phosphorus, this white phosphorus it is now converted to red phosphorus, which is now in a solid state. Therefore, it is very stable. Hope it makes sense. So now let's see. Kuti atamene kuti white phosphorus ni chani, atamene kuti red phosphorus ni chani. Let's go to the allotropes of phosphorus. Allotropes of phosphorus. Allotropes is defined as different forms of the same element at the same physical state, distinguished by structural arrangement of atoms. Tikamakamba za allotropes timakanga tili ni element imodzi ndithu element like phosphorus or element otchedwa carbon or oxygen. But that element at the same physical state upanga belong to two forms. These two different forms they are just distinguished by the structural arrangement of atoms. So the allotropes of phosphorus, we are having white phosphorus and red phosphorus. So now let's see what are these white as well as red phosphorus. White phosphorus, it tells some of the facts about white phosphorus are as follows. This one, it turns pale yellow when exposed to air. It is a self-igniting and catches fire easily when exposed to air, like zimayage. Because of this, they should be kept under water. Remember, like ni air umaso water tazipanga mix. Then air, because it is less dense, ipanga settle at the bottom. Then water, air will settle at the top, while water will settle at the bottom. So this phosphorus, it is kept under the water, like we are separating it from the air so that it should not catch fire. Another fact about what phosphorus, it produces a poisonous vapor. Then it is a very stable phosphorus, hence it is most reactive. Then it is also highly toxic. Ndeti zamakamba za white phosphorus kwaukulu tizoona kuti it is unstable compound which is most reactive. Then white phosphorus is just an opposite to red phosphorus. Mean to say the opposite of the following, some of the following it will define the properties of red phosphorus. Let's look at the red phosphorus. Red phosphorus, in terms of their properties, it is very stable at all temperature. It is very stable. At all times, it is in a solid state. Because of its stability, it does not catch fire easily. Paine white phosphorus tinaona kuti it catches fire easily because it is unstable. And this red phosphorus, it is formed by heating the white phosphorus. Red phosphorus imachokera ku white phosphorus. Remember, in the extraction process of phosphorus, product yathu type of phosphorus amene tumpanga produce, it is white phosphorus. So this white phosphorus, which is unstable, it is converted to red phosphorus. These are the allotropes of phosphorus. A question can come. State two allotropes of phosphorus. The answers are white phosphorus as well as red phosphorus. Let's go to the physical properties of phosphorus. Remember, the properties are divided into two. How about the physical as well as the chemical properties? So now let's see the physical properties of phosphorus. First, it has low melting and boiling point compared to metal elements. Low boiling point and melting points. Another physical property, it exists in two forms. These two forms are also called the allotropes. Like we are having red as well as white phosphorus as their allotropes. And this phosphorus, it is insoluble in water because it is a nonpolar element. Remember, phosphorus it doesn't conduct electricity because it is a non-metallic. This is a non-metallic. In terms of its solubility, it is also a non-polar element. Meaning to say it does not dissolve in water. So non-polar, it goes with non-metallic. Ngati chinthu sikupanga conduct electricity, therefore that substance cannot dissolve in water. Since it is insoluble in water, therefore it is soluble in organic solvent. It is soluble in organic solvent. Example, we can have benzene. Benzene is an example of organic solvent. Let's go to the properties, to the chemical properties of phosphorus. Phosphorus, in terms of their chemical properties, it reacts with oxygen. Okay, phosphorus reacts with oxygen to form phosphorus pentoxide. The phosphorus pentoxide is a compound which is formed from two different elements. Like we're having phosphorus, pentoxide. Anything which reacts with oxygen, it means it burns readily in oxygen. That element or substance, it supports combustion. Kenaka kosi kamene kapanga react in oxygen, just know that it supports combustion or it supports the burning process. Below we are having our equation that phosphorus reacting with oxygen, it forms phosphorus pentoxide. Okay, this is our chemical equation, or this one it is our word equation. The chemical property number one of phosphorus, it is reaction with oxygen, or you can just write it supports combustion. Tamakamba za combustion ndoti pachika reaction with oxygen. Then another chemical property of phosphorus, it is the reaction with chlorine gas. Reaction with chlorine gas. Let's say chlorine now. Yeah. So this phosphorus, it burns in chloride gas to form phosphorus trichloride. Tri means three. Mean to say our compound which is called phosphorus trichloride, it is formed from the elements of phosphorus as well as three elements of chlorine. Then molecular formula it is PCl, which is our chlorine, then 2. Then it has to be 3, not 2. Just typing error. Because we are having tri means 3. Therefore, this one has to be 3 as well. And this process with the chloride gas, it also forms phosphorus pentachloride. But it forms phosphorus pentoxide when this chlorine it is in excess. Ngati pali excess of chlorine, our product will now be phosphorus pentachloride. Pentachloride. Pent means 5. Like timeona zama we had this kumasamu form 2. How did this called pentagon, hexagon, nonagon, decagon? Mazikumbukile. So penta means 5. Mean to say this compound called phosphorus pentoxide, we are having 1 phosphorus as well as 5 chlorine because of the word penta. Below is our chemical equation, which says phosphorus reacting with chlorine, it produces phosphorus pentachloride. The main chemical property for reaction of phosphorus with chlorine gas. Let's chemical properties taona kuti zilipo zinthu ziwiri. First, reaction with oxygen. Second, reaction with chlorine gas. Let's go to the uses of phosphorus. Phosphorus, it is used in the manufacturing of match heads, like Dimitru Tamagisa Amerimatlamor. So those match heads have got the component of phosphorus. Remember, on the allotropes of phosphorus, we have white as well as red phosphorus. So on the white phosphorus, we have discussed that it is very unstable and it catches fire. It catches fire easily. That's why those match heads have got the element of phosphorus to catch air more easily. Another use of phosphorus, it is in the manufacturing of detergents like surf. Detergents zojabila kapena zopha infection like surf, my disinfectant, like that. It is also used in the manufacturing of fertilizers like NPK. NPK has got an element of phosphorus because NPK is nitrogen, phosphorus, potassium. Okay. It is also used in the manufacturing of light poison. Poison of pharmaceuticals, light poison. It is also used in the bombs to release energy. This marks the end of our class of today about phosphorus. Then in our next classes, tidzayamba topic ina. Lero abakanga taona za nitrogen, sulfur, komanso phosphorus. So before closing, we have 9 minutes for our Microsoft Teams to close. So anyone with a question before closing? Anyone with a question?